This is a key to 4.1 part 6, and on this worksheet you're using the formulas for compound interest. And so the two formulas you're going to use are these. So you're going to use the formula where you have A equals P times 1 plus R divided by N raised to the NT power. And the other one is A equals P times E to the RT, where R times T is the exponent. All right, now remember you're going to use this when you're told that it's being compounded continuously. That's when you use this. Okay? And you're going to use this when it's being compounded a finite number of times. All right? Okay, so in number 1, and remember you are don't forget to approximate to the nearest cent. So the nearest cent, remember, means the nearest hundred. Okay, so number 1, it says find the accumulated value of an investment of $20,000 for 3 years at an interest rate of 6.5% if the money is compounded semi-annually. Okay, so keep in mind that for that one, number 1, semi-annually means twice a year. Okay, so every 6 months, so to speak. So N is the number of times it's being compounded per year. So you're going to use this one. The only time you use this one is if you're told it's being compounded continuously, like in this example right here. Okay? So in this one, to the setup, you're going to say this. You're going to say the accumulated value will equal the principal is how much you invested, the initial amount, which is $20,000. All right? Times 1 plus the rate. The rate is 6.5%. You must write that as a decimal. So 6.5% is 0.065 divided by N. N is the number of times being compounded per year. So here, semi-annually means N is 2. That's what that means. All raised to the, and I'm going to put that in parentheses. It's important that you put these in parentheses so you don't mess up on your calculator. So N times T. So N is 2. Times the time, which is 3, right? Okay, so there's your setup. So your setup, you're going to put that there. So you're going to say setup is A equals 20,000 times 1 plus 0.065 divided by 2 raised to the 2 times 3 power, and you could have said 6. All right, now let's use a calculator. So on your calculator, though, you got to be careful. So on your calculator, if you have this kind, you just punch it in as you see it. So you're going to say 20,000, all right, times, or just put parentheses, so that means multiplication as well. 1 plus 0.065 divided by 2, close the parentheses. Now you got to raise it. So here's your exponent button right here. Raise it, parentheses. Now the reason why we use parentheses is because this could have been a decimal, like 3.25 years or something like that. All right, but that's easy. 2 times 3 is 6, so that's easy to where you could have just said 6 without parentheses, and then enter. Okay, now to the nearest hundredth, to the nearest cent, so you're going to have $24,230.95. All right, now if you had put parentheses, here's what you would have done: 20,000 times 1 plus 0.065 divided by 2, close the parentheses. Oops. Let me do it again. So 20,000 times, in parentheses, 1 plus 0.065 divided by 2, close the parentheses, raise to the parentheses 2 times 3, close the parentheses, equal, and you get the same thing. Okay? All right, now the only difference between A and B is that everything else stays the same except what's different in both cases, A and B. Well, it's the N, right? So if it's being compounded quarterly, that means N is 4. So every 3 months, so 4 times a year. So you just change the 2 to a 4. So we're going to get A equals 20,000 times 1 plus 0.065 divided by 4 raised to the 4 times 3 power. Okay? All right, so using your calculator, And so we get 20,000 times 1 plus 0.065 divided by 4 raised to the, and then 4 times 3 is 12. I'm just going to put 12. And we get $24,268.15. Okay? All right, now keep in mind as you do this, notice that the accumulated amount keeps increasing. Make sure you understand why. Because your interest is being compounded more times a year. See, this is just 2 times a year. This is 4 times a year, so the interest is earning interest a little bit more. And then compounded continuously, this would be more, but not that much more depending on the years and the interest rate. All right, so compounded continuously, you're going to use this. So you use the PERT formula, P-E-R-T. So you get A equals the principal, which is 20,000, times E. I'm going to put that in parentheses. Now, this is where the parentheses is necessary because my rate's a decimal. So put parentheses here. 0.065 times the time, which is 3, right? Now remember, that's where the parentheses can be important. You need parentheses here. All right, so let's do it correctly. So we're going to say 20,000 times E. Find your E button. Remember, your E button's right here. You got to press second L in to get to it. You see it? Now, I already put parentheses there for you, so it kind of helps you out. If so you're not going to forget because it's already there. So say 0.065 times 3, close the parentheses, and press equal, and there we go. So $24,306.22. So notice it's a little bit more than this one. All right, so the more times you compound, the more money you get. Okay, number 2. So find the accumulated value of an investment at $10,000 for 4 years at an interest rate of 2.5%. So it's the same. You can do the same thing, except this time the numbers are different. All right, so compounded monthly means yen is what? How many months in a year? 12. So we're going to get A equals. So we're using this formula. Remember, this is the formula you're using. The only time you use this is if it says compounded continuously. So A equals 10,000 times 1 plus the rate, which is 0.025. Remember, you must convert that to the decimal. Divided by 12, all raised in parentheses 12 times 4. Okay? Or you could say 48. All right, so in your calculator, you're going to say 10,000 times 1 plus 0.025 divided by 12, close the parentheses, raised to, open parentheses, 12 times 4, close the parentheses, press equal. So you get $11,050.56. Okay? All right, now let me tell you what's going to happen if you're not careful. So you're going to say this. Okay, watch. Some of you will forget about this. See how I put parentheses there? All right, so you're going to say 10,000, 1 plus 0.025 divided by 12, right? Raised to, now see if you don't put parentheses and if you leave it as 12 times 4, watch what happens. Okay, we'll say times 12, right? And then times 4. Notice I didn't put parentheses. That's an error. I didn't put parentheses. Watch what happens. I'm going to get the same answer. Because what happened, let me go to it, what happened is this. So see how I'm raising it to the 12 and then multiplying by 4? What happened was this right here was the only thing being raised to the 12th power, and whatever that was, then I'm multiplying by 4. But that's not what that says. Okay? That says that all of this has to be raised to that power, not 12, but 48. So that's why you need parentheses there. Okay? Or you can just say 48. So you got to be careful. All right, and then finally, continuously, we have E equals 10,000 times E to the, and then the rate is 0.025 times the time, which is, in this case, 4. All right, so let's use the calculator. So you're going to say 10,000, 10,000, yep, times E, okay, 0.025 times, and then what, 4, times 4, and then close parentheses, and then press equal, and you get $11,051.71. Okay, so notice it is more, but not much. You can see this is n equal 12. So if it was quarterly, it would be less than that. If it was semi-annually, it would be less than that as well. Okay? All right, number 3. Suppose you have $15,000. And which of the two rates would yield the larger amount in 3 years? 6.12% compounded quarterly or 6% compounded continuously? All right, show your work. All right, so what I would do there is let's look at the 6% for 6.12%. So 6.12%. Let's look at that. All right, so let's look at the accumulated value. So the accumulated value will be 15,000 times, remember it's being compounded quarterly, so I'm going to use this one. The continuous one, I'm going to use this one. All right, so 15,000 times 1 plus the rate, which is 0.0612, divided by quarterly, so that's 4, all raised to the n times t, and t is 3. All right, so I'm going to get 15,000 times 1 plus 0.0612 divided by 4, close the parentheses, raised to, parentheses, 4 times 3, close the parentheses, and then press equal. So 17, so that's about 17997.99, right? Okay, now let's do the 6%. So for 6%, I have the accumulated value will equal 15,000 times E to the rate is 6%, so that's 0.06, right? Got to use that percent. Times the time, which is still 3 years. And let's see what that is. All right, so 15,000 times E raised to the 0.06 times 3. Close the parentheses, press equal, you get this. So $17,958.26. Okay, so if you're comparing two different investments, one, the same amount though, one 6.12% at compounded quarterly, and the other one 6% compounded continuously. In this case, the one that's going to give you the more money at the end of 3 years is this one. Okay, so this is your work. You're explaining your answer. So which of the two rates would yield the larger amount in 3 years? So you'd say the rate of 6.12% will yield the larger amount in 3 years. Okay? All right, so that is the key to Worksheet 4.1, Part 6.